Hello, friends of .NET. My name is Immo Landworth. Welcome to the, 646th episode of the Community Stand-Up. I have no idea how many episodes we have. So today I have a bunch of fantastic people with me, and I think we should probably start with introducing themselves from the top left to the bottom right. Jared?
I'm Jared Parsons. I'm the C# compiler lead. On my screen, I'm in the bottom right, not the top left. So,
But as we discussed, my screen is the one that counts because that's what everybody else is seeing.
But that means you have to tell us which order we have to.
Oh, I see. Okay. Then Fred is the next.
Hi, everyone. My name is Fred Slipelberg. I am a compiler developer. I work for Jared, and I'm a member of the C# language design team.
Andy?
Hey, I'm Andy Goki. I work on the C# language design team, and I also am a compiler developer on C# and VB.
And then there's Mads.
Yeah, hi, I'm Mads. I'm not on the C# compiler team, but I am also a C# language designer, so I get to be here with these guys.
That's awesome. So today we want to talk about everything related to C#, right? So people in the chat should ask questions. Anything you always wanted to answer it, now is your time to ask. And every once in a while I will go with the questions and hopefully get you some cool answers. And other than that, there's some cool demos that I think we're going to do. So now I hand it off to the other people.
The other people.
Like you guys, the important ones.
Okay.
That's
fair. So I guess we're here to talk a little bit about where we are planning for C# to go next. And one of the things that we've been wanting to do for a long time is to do something with what is commonly called records. The general idea, loosely speaking, for many years has been, can you do sort of more abbreviated data types where you don't have to say so much boilerplate? And can they also be more like values, more like data and less like objects and so on? And so we've finally gotten into full think mode on that. And we're pretty far along. Andy's built a prototype. We can, well, it's actually implementing now, but we have some public bits that you can access in SharpLab, for instance, that we can play around with a little bit that are sort of very early on that. And we can also talk about how we envision the bigger feature set. So I think that's kind of what we're planning to show for a bit. So should we dive just right in and talk a little about records?
That sounds like a good plan to me, yeah?
Yeah, all right, well.
The time will fill by itself. I'm not concerned about time.
Okay.
we never quit early.
Okay, all right, hang in there, guys. So I will start by sharing my screen then. I got elected to be the person bringing up SharpLab. So let me share this screen here. And I just want to confirm that I'm showing things. Am I showing things?
Yes, you are showing things.
I can certainly see it.
Great. Okay, good. Let's not wait for it to show up on the stream because there's a little bit of a lag here.
Yeah.
So the idea is essentially that you want to write something very short and you want to get a whole lot out of it. That's the evolution of C# right there in a nutshell since V1. But the syntax that we have in the bits currently up there, it's probably going to change, is that you can say data class instead of just class. Put some kind of usually a class name. You can either in parens or in curly braces, but right now it only works for parens. You can put some things that you want your class to have, like first name, last name, and that's it. And now I've written a record. So this is the kind of experience that people have been asking for. And now, if you notice on the left here, or sorry, on the right, you see that a whole lot of C# got generated all of a sudden. It generates a property. It generates some equality, and there's more that it will generate that is not in this in these bits yet. But we can see now if we go to the program and start using them, I can create a person. I do indeed have a first name, even though it looks like I just declared it as a parameter here. It's both a constructor parameter and it's a property. It's actually it's a getter only property, so we expect these guys to be immutable. So if I go and say, oh, by the way, change my first name to Andy, then I'm going to be told that I can't. It's immutable. But what I can do is I can create another Mads, and I can compare the two and run the program. And what you'll see, if I did things right, is that those are considered equal, even though they're individual objects that were created separately, because they're value equals. So this includes not just removing some boilerplate around the creation and the members of things, but also automatically implementing value equality for you that's per individual member. So that's a general idea here. Before we dive in, maybe let's see if there are some questions or other people who want to comment on, like my colleagues.
Yeah, so one question we got is, will it support mutable properties?
Yeah, I think so.
It should. Let me see if this works in my copy of SharpLab before I say anything about it. But the idea would be that these are kind of the default implementations, and that you can provide your own implementations if you want. So if you have a auto-generated property called first name, you normally would be able to type it out yourself and then make it a get set property.
I'm gonna try to. I'm brave. I'm gonna try to do it right here. So if I say public string first name get set.
Yeah. So it works. The only missing piece is that it's not initialized in the constructor right now, because of design issues of how that actually happens. So that's what's unimplemented. But the idea is that because you wrote a property named first name, that's the first name property.
Right. So if I go here and change it, I say mads.firstname equals Andy. You would indeed be able to, because you wrote the property yourself now. So the generation of the properties is really just a default. And if you want it differently, you get to say how.
Yep. And that's also true for equals. If the default is value equality, but if you decide, oh, no, I have some kind of more complicated thing I need to do, then you can write out equals yourself.
Okay, that's gonna something. If I did that right,
that's not an override because it doesn't have a second parameter. It's just an object parameter.
Oh yeah, it's the
and then this is the other.
Yeah, you're right. So there you go. So now it's false because I overwrote the equals. Now they don't compare equals anymore. Okay. Does that take us through most of what these bits are capable of, Andy?
Yeah, that's pretty much what's been implemented so far. Some things that are in review right now. Structs work. There's an interesting side effect of language details where structs always have a default constructor. So that's a bug that isn't fixed in this version. And then I'm currently working on with expressions, which is what we're thinking of as non-destructive mutation. So the ability to say, I have a record that's Mads, and you can change the first name, but you don't mutate the first name. You produce a copy of the object with the first name modified. Right. And that's a way to keep immutability, but also have kind of copying in an immutable world.
Right. So you would be able to say something like var
Mads with
equals mads with
open brace.
Open, and then we can say first name equals Andy. So this is object initializer syntax applied to an existing object to get a new object. And that way we support strongly typed non-destructive mutation, where and we will do it in such a way, we haven't talked about inheritance yet, but we'll do it in such a way that the new object will be a copy included, like with the same runtime type and everything, but only with the things changed that are specified in the object initialize.
Yeah, and unlike some of the other language record implementations, this one should be robust through inheritance, so that you can, so that equality will continue to produce the correct default result, and have customization along those axes.
Did you do anything with inheritance yet in these bits?
No, there's actually no syntax because the base with arguments syntax doesn't exist yet. So in theory, it actually should work, but like there's no way to test it because the syntax is invalid.
Syntax isn't there. Okay, because what we envision here is that you could say something like student, take the same parameters and another one. So I'm just going to type erroneous code in here, comma int ID, and we could say that inherits person passing on the first name and the last name as arguments to its constructor. And then, and there or optionally provide a body for that. So that records and inheritance work together. And that's actually, we think, a relatively important scenario, not just because we happen to be in an object-oriented programming language, but also because this is probably the way that we envision that people will model what you could call discriminated union scenarios, where you can think of where you have a fixed number of options of different shapes, different types of a given thing. We would model that as kind of a limited inheritance hierarchy where there's nothing or not much in the base class, but then the derived classes would have structure and would have content, and that would be describable as a hierarchy of records as well. Okay.
Emo, if you're talking, you're muted.
Yes, I'm muted. So one question in the chat was, will it also work for structs? So can you say data struct basically instead of just saying data class?
That's in review right now, actually.
Yeah. There's the background is it doesn't exactly fall out of the proposal of the implementation as written, because structs have two implicit constructors and classes only have one. They only have the implicit constructor that is produced when you don't have a constructor, and that one is synthesized. But structs always have an implicit parameterless constructor. And so that's a bug in the current implementation because the implementation was not expecting two synthesized constructors.
Right.
Right.
So this is definitely a first foray into records, just so we could start getting some of the implementation worked out. But as we've been talking more about records, and this sort of embodies the core of what we've been talking about for a long time, but as we've been talking about records, we've started thinking about it more and more in terms of, to some degree, separable features that are useful in their own right. Like records do a lot of things. They're like a Swiss Army knife of expressing data. But some of those things that you can do with records, or that we envision that you can do with records, might be more useful that you can do in general. And so we haven't built any of that yet, or not in some of it we have, but some of it, but then not in shareable bits. And And so we can switch to slides and talk about some of those elements that we're starting to see more as a kind of, let me start bringing up the slides while I talk here, more as a sort of, maybe if you think about LINQ, language integrated query, that came into C# 3 so many years ago, 12 years ago we shipped LINQ. And LINQ was, on the one hand, let's actually go straight to some more interesting slides here.
So before we do that, like, there's some more questions that are for the record stuff, because I think you want to talk about other stuff probably now, right? So one question
I'm
was.
going to talk. Yeah, we're going to keep talking about records, but let's keep with the questions that are coming in. Let's take some questions. Yeah.
Yeah. So one question was: is the width thing a CLR thing or a C# thing?
The width thing is a C# thing.
Yeah, our most recent proposal for how width will work is that we are going to take advantage of the CLR's non-required behavior in the face of read-only. Effectively, if you have a read-only field, that's not actually a read-only field according to the CLR. For example, Go compile an application referencing a library where the field is mutable, and then change the field, and then go back and recompile the library, but add read-only to the field. Your application will continue to run just as it did before. That's because modifying read-only fields is a compiler error, and it's unverifiable IL, but it's correct IL. And this is for instance fields only. Static fields actually read-only matters there, but for instance fields, it doesn't. So because it's all compiler safety effectively, very few things actually enforce verifiability. That means that we can kind of take advantage of this functionality to build a feature where we know that a field is read-only, but will allow you to set it in very restrictive circumstances, like an object initializer, where there's no way that you could possibly see the field being changed, or very few ways that you could possibly see the field being changed, approximately the same as current read-only. And that's effectively the same security boundaries that we had before, but allowing a few more features, including object initializers that could set read-only fields and with expressions that could set read-only fields. So that's the functionality that we're envisioning to power with expressions.
Mm-hmm. Which, yeah, we do have some with expressions in the slides as well. We can talk about that feature a little more as we get there.
Yeah, the other question for withers was, are you considering supporting dotted access, like with a.b.c equals some value?
No.
It's certainly been a proposal that's been talked about on C# Lang. We have been more focused on getting the core features out before kind of building up the extensions. That particular feature is kind of nested withing is an interesting idea that we'll need to talk more about. There's some scoping stuff there that's a little bit tricky. And then there's the simple aspect of the fundamental idea behind that is that you would be able to take what in C# terms would be called a simple identifier, that is like not a dotted name, and have that simple identifier refer to kind of a nested construct. So in the with expression, the idea would be that you would be able to take a property and say, this property is also withed. Mm-hmm. So you would have nested withing, essentially. But the property in the with expression doesn't get, there's no receiver. There's no left-hand side of the dot.
Right.
It just kind of implicitly says, oh yeah, whatever is on the left-hand side of the with expression, that's the receiver. And so that's, if you think about it, a kind of more general feature where we treat a simple identifier as being a component of a scope that is there simply because of the context. We have related features like that. And so if we want to do something consistent for all of them, we'd probably need to consider all of them together. we have a general proposal, for example, that would work for enums. Today, if you said, like, if you created a local variable, enum color, and you assigned color.red to it, you actually have to say color.red. You would either have to say using static color, or you have to say color.red. You can't just assign red. But you could envision that that could be loosened. That because you're assigning to an enum called color, we could maybe bind the simple identifier in the context of the left-hand side and say, okay, color isn't an identifier in my program, but it is the name of a property in the enum. Could I just use red from the enum? And so that's like kind of the same feature if you squint. And that those would be the kind of things that we would want to consider together.
I think another interesting thing there is collection initializers. So that's another way in which you can envision the with expressions being expanded to be able to reach more deeply and make other kinds of changes than just swapping out the value of a given property directly. So it's definitely there's a path for us to grow there, which we haven't really mapped out yet, and probably won't do in the first version of it, but that are great things to consider to grow into.
Now, one though is that we keep talking about withers here, and kind of like the most recent iteration of records, like withers are really just a way of doing object initializers, essentially. Wouldn't we just consider expanding this for all object initializers?
Yeah, I think so.
So it's not just like a withers construct. Like we would,
right.
This little dotted syntax would work for structs buried inside of initializers.
Maybe, because the thing is that the initializer, the difference is that the with expression has an obvious receiver, and it's not the thing being withed, right? It's not the thing after construction. It's the receiver on the left-hand side of the with. Whereas if you do it in an object, if you do it in an object initializer, then the only receiver is the one that you're actually creating. It's this. So it's a different object.
That shouldn't impact our ability to like initialize struct values though.
Ladies and gentlemen, you've tuned into a live C# design meeting.
Yeah, maybe. I don't know. That's a good question.
I think that if you play it out, like if you think about like the things that are being dotted in through as structs, that it would just be a general. We would have to make some decisions on the initial, like which the implicit receiver was, but it would still be the same fluidity.
That general idea is, yeah, that's got legs. And similarly, right now there's actually no cooperation between with and collection initializers, but that's also a reasonable question to ask. Like, well, what if I wanted to modify the elements of a nested collection? Not modify as in replace, but add, remove, whatever. It's a good question.
Create another version of the collection that gets included in this other version of the original object. Yeah, it's that recursive withing that we talked about before.
Yeah, and that one makes sense in the general idea of when people are talking about immutable data structures. It's actually pretty common, especially with even if you look at our immutable data structures, to end up wanting to kind of create a copy and then have an element appended or something like that. So.
Yeah. Okay, so are there more questions we should dive into right now?
So the only other question was about serialization, but
remember I muted you again because you were making noise.
Can you?
Doesn't he always?
Oh, I see.
You're still muted.
Okay, so now I'm muted. So the question is about serialization.
What about it?
So basically, how would it work with serialization? I guess is the question.
Saying does it work with serialization is, I'm going to pull out my little hill to die on. Which serializer are you talking about? Serialization is completely ambiguous. We could be talking about JSON serializer, Newtonsoft. We could be talking about data contracts, WCF. Barry Doran's serializer, also known as binary. Which one are you referring to?
If we make it work for binary serialization, That is, if we explicitly include some support for
not.
binary serialization, Barry is going to come to my house. So I feel like that
I
one.
live too close to you, so he'd make a stop at mine. So binary serialization is something like this was discussed recently with, I believe, we had a discussion of some runtime recently with, I believe, a mutable array or a mutable list or both of them. And the decision for that is kind of what's going to hold here, in that there are a number of types in the runtime which have binary serialization, and that's there strictly for compat. Like that is something that we had to do for compat, but we're not adding new types to binary serialization going forward.
Yeah, I guess the general question is, like, in order to support serialization, I guess you have to either be able to put attributes on members or be able to implement interfaces, right? I think that's, I guess, the general question of like, how would you make the type work with a particular serializer?
Yeah, so I think records would definitely be able to implement interfaces. That's fundamentally they're very similar to structs and classes. As Mads showed in the prototype, you can put open close brace and basically write a full class body. There are very few limitations on the kind of things you can do. There's a set of defaults that come with the feature, but it still is very C#-like in that it really does allow for full objects. And that means that you would certainly have interface implementation. As far as any kind of attributes go, certainly the syntax that Mads showed, where you kind of replaced the property, the default property with a new property, there's an easy place for an attribute to go there. There are certainly things that we can do and things that we'll think about in terms of attributes and how we want to support them in general on properties. But there's certainly no like abstract limitation. We just have to figure out exactly how the syntax and the semantics work out.
Right.
But I assume that that's going to be a big, that's something that we will have to solve. Putting attributes on properties is a big deal. Yeah.
Makes sense. I think this was all the questions regarding the record feature.
So one thing that kind of struck us that has always sort of been a bit of one of the more painful aspects of object-oriented programming, and certainly in this sort of family of programming languages, kind of came to the front even more as we were talking about records, which is the pain around constructors. We've sort of been nibbling around the edges for a long time around the pain of declaring how a class is or how an object is made from a class. If you look at a classic class here, like person, there's a lot of the code here, like essentially 5 of the 7 lines in the body are obsessed with the creation of it, and you can shorten it in various ways, but most of the code is about how you create it. And if we start using inheritance, then it gets worse, because not only are you adding the same amount of overhead for the new members that you're adding, new data members you're adding, but you're also having to repeat things and pass on things from the base class. And so the deeper your hierarchy gets, the bigger your constructors get, and it's all sort of boilerplatey. And so in C#3, we introduced an alternative, which is object initializers, where instead of all that quote-unquote gunk, maybe you should just declare your members, and the derived class can also just declare its members, and then object initializers are all you need in order to create a new instance of the object. So the introduction of object initializers really gave you this we could call nominal form of creation, where yes, you have to say the names of the things you pass in, rather than just relying on the positional identification of them that are in constructors. But on the other hand, that both gives you flexibility as you're creating it, but it also means that it's straightforward and simple to write the classes, and there's no essentially there's no repetition anywhere. And that's really nice. And not having a lot of gunk seems to be like a goal in and of itself for records as well. So we started looking more into nominal again. The main problem with nominal creation is that it relies heavily on setting the properties after the object is created. That's how object initializers work. First, the object is created, the constructor runs, then you assign to the properties of fields. And so it's strongly tied to mutability. Whereas for records, we're very focused on helping immutable scenarios as well, even by default. So that's sort of that's a painful disconnect that we wanted to address. And that's where we came up with init-only properties and probably init-only fields as well. We're discussing that right now, where essentially the idea is instead of a full-on setter, you can specify an initer, an initializer, or whatever we want to call it, an init setter. And that's just like a setter, and you can specify it manually. It doesn't have to be in an autoprop, except you're only allowed to call it while the object is still being initialized. That is during the object initializer phase here, or during a with expression, if you're using withers that we talked about before. And then once you reach the end curly here, the setter goes out of scope, so to speak, or becomes illegal to call. So this gives you the read-only, the immutability that you need, but also the flexibility to declare things this way and to create them in a nominal fashion. And we touched on that already a little bit with how with the read-only stuff that we discussed before. So this is something that we feel should not be tied to records as like only be available when you declare a class to be a record with the data or record keyword or whatever. But that should be available everywhere in any class declaration or a struct declaration that you have. So that's an example of how separate features kind of flake off of the work on records.
And also a potential that would be a potential other avenue for serialization. That because those properties are user declared, there's a great place to put an attribute for them.
Yes, yeah, that is true.
And for deserialization, the deserialization library might have to look at the metadata to figure out that that's an init property, but that's a pretty straightforward thing. Plus, deserializers actually set read-only properties all the time right now, so it actually might just work. They kind of play it fast and loose with the rules.
Right. In a sense, these init-only things are certainly better for deserializers to call than straight-out read-only things, because these are made for being initialized. They actually declare their intent to be initialized when the object is created, which is kind of like, that's okay for a serializer to do. It's actually less okay for it to just go poke values into objects that are strict read-only, and yet they do it. So, yeah. Any questions or things in that?
The one question was, is that for C#9? I think you probably should talk about like what is the thing that you're describing here? What are you looking at? Is it a hypothetical, or is that something that is kind of in the plan coming?
Jared is the planner, but I think that this is something that we would definitely want to get into C#9. We could run into
for init
challenges there.
Yeah, for init.
Oh yeah, init is likely, honestly, like sorry, I had to like drop off for a second. An infrastructure issue happened I was dealing with, but I don't know if we talk about the fact that init is a building block of records, and one of the things that we really feel important is the ability that records in some ways like is kind of an implementation detail. Like, should you as a consumer of a record, if I switch it from a record to a normal class, should you know that? Like, or is it something where I can take a record and convert it to a normal class, have all that boilerplate code kind of like spit out into, C#, and will my consumers be kind of ignorant of the fact that I did that? And so that means that when we kind of start talking about things like init as a way in which records work, it's like we're kind of in some ways pushed to make sure that that's a part of the C# feature base so that you can make records essentially an implementation detail to some degree. And so I think that I would say that it's, if we ship records and init is a part of how we rationalize how all of this holds together, that it's going to be a part of the language.
Yeah.
Yeah, the at least the with expressions right as planned are going to depend on that. So it's certainly scheduled for the same release. This isn't kind of an optional follow-on component.
Right. Yeah, it's really a core element of making records work the way we want to. Here's the thing that may be further out into the future, but we certainly have to make sure that if we ever want to do it, we get the design right now. Again, it's down to one of the things you can do if you have, if you rely completely on positional object creation, like on constructors doing the heavy lifting. If you can trust that the constructor has all the data that is going into the object through its parameters, then you can do some validation in there. That's whole object validations. For instance, here, just checking that the combined size of the name isn't too long. And this kind of whole object validation is, at least occasionally useful. I think that most of the validation that happens actually is probably per property. But sometimes you really do want to do that, or you want to do some whole object final initialization or something like that. And object initializers sort of by design can't do that because they don't run any centralized code. Certainly not after the values have been provided. So we talked about, and this is just a straw man syntax again, everything here is really a straw man syntax. We talked about having something that we've called validators, or I don't know, the many things are called initializers already, but they should really be called that. Initialization finalizers, which is a new kind of member declaration that is like a constructor, but it gets run after all the object initializers have been called. So essentially, at the end curly here of the object initializer, after the client here is done poking values into the properties, they're compelled to call the validator and run that on the created object. And that's sort of the last chance to check that everything's okay and set the last bits and pieces according to the data that came in. And that would essentially take care of the whole object validation in this more nominal approach to initializing objects. Again, this is a separate feature. It's regardless of whether it says init or set here or whatever. It's a separable feature that would also happen to benefit records, but can be done on its own. So that's another thing that we're thinking of doing and making sure that our designs will work with and evolving them. But I'm less sure that this one will make it into V1. I think that's probably a discussion about how critical is whole object validation. Can we ship records without that?
So one question that was asked is, can you have get, set, and init? Or is set and init basically mutually exclusive?
That's a good question. We were just discussing it the other week. We're really looking at, this is hot design stuff that's going on right now. Our tentative plan of record is that you can't have both. Generally, you would want, except in very contrived cases, unless you have a real good scenario, then shoot it to us. You probably want the same code when you initialize and when you subsequently set the properties. So we don't want to separate them. We just think of init as a setter that's limited in time, can only be used during initialization.
In that sense, set is effectively a superset of init.
Yeah, it's a sloppy init.
And then I think the other question was, will it be possible to mix a parameterized constructor with init arguments?
Yes.
Be able to. It should just be regular constructors, basically. I mean,
an object initializer allows parameters and then or arguments and then the properties. So you should be able to do both.
Yeah.
Yeah. This feature should fit into existing constructors and existing object initializers where you can already mix this type of thing. So you should just be able to continue mixing them.
Yep.
So some people in the chat are asking, what is a wither?
Let's get to that.
Okay, listen, if you're going to ask about that, like, you should do it properly. You need to say, like, what is it with withers? Like, you got to get, like, the double with, into the question.
What is it with withers? Yes.
Every
Yeah,
question
come back to
has
us.
to be a tongue twister.
Come back to us with withers, and then we'll talk about it. It so happens that I have slides, so I'll pay you later. This is an idea that is kind of old in C# language design terms, in that I think Jared came up with it 3 weeks ago, maybe a little longer. And you're muted, Jared, in case you're.
No one wants to hear my laugh. Like, people were.
So the idea here is that maybe so we have a little detour to another possible generalizable feature that would happen to work well with these things, and that's the idea of factories, or we've also called them constructor methods. I'm using factory here as a straw man for it. Maybe you can. So let's say that my class has a protected copy constructor, so to speak. It's one that creates a copy of an existing person, initializes this new person to be a copy of an existing person. Okay, that's easy to imagine. Now let's say that we have a method called with that is virtual, and it creates a new person as a copy of this person that it's called on, and then it's marked as a factory method. Okay, and student might have the same thing, but it overrides the with method to create a student that's a copy of this student instead of creating a person. So the with method is virtual, and it will return a copy of the object itself, and the virtual methods will be overridden to make sure that it's actually a copy that preserves the runtime type and copies all the properties, even though or fields, even the ones that aren't statically known to the caller. Now, with this infrastructure in place, we could allow that, because it's marked factory and limited to only return new objects, we could allow you to call the with method and then apply an object initializer to that call. So essentially, when a factory is called, you can apply an object initializer to the result. Now, wouldn't that be a useful feature in general? I got a fresh object back. The method guarantees that it's a fresh object. It hasn't been leaked to it. People haven't been able to observe its current state. So you can still override some of its properties. That seems like a generalizable feature, but it also is a way that we can implement the with feature. We could maybe even allow you to not put the parentheses if the method call has no parameters, just like we do with object initializers today. And then the with syntax that we showed before would really just be syntactic sugar for calling the with method. I think that's kind of neat. It may be more general than we need for the with feature, but I can actually see a lot of scenarios where using that factory feature would be useful.
And one thing we were kind of looking at when we were talking about, is this something worth generalizing, or is this something like we should just make it specific to with? And you can actually even look through the BCL to see a number of places where type authors have essentially like opted into factory methods. And one of the reasons why you'll find pretty commonly is generic inference. So pretty much anytime you have like a generic type, which has a lot of constructors, like tuples is one, all of the more kind of modern collections that we've built with builder patterns, what you'll pretty much always see is this pattern that we have, which is you define the generic type, you have like a mutable array, has all of its constructors, and then you have the non-generic type, which is just a static class that has a whole bunch of create methods. And what that allows you to do is really take advantage of inference, because then you can say var array equals immutable array dot create instead of new immutable array, like open paren, like type out all my tuples, type out all of my like delegates. It's like, no, just do immutable create. But at the same time, even though that's a good pattern, and it really kind of, it allows type authors to kind of really feed into the C# inference system, it's forcing them to have a trade-off. It's saying, hey, yes, you can feed into inference, but you lose object initializers. Like you have to make this trade-off. And this generalization here is basically a way of saying, hey, we have this pattern, and this pattern is all of these factory methods, which all they do is create objects. Why are we opting them out of initializers? We can basically let people feed into the inference algorithms with C# while still giving them the flexibility to use object initializers. And so it's basically finding this friction point and tension point in the language where we're making developers choose between two good features and saying, no, actually, you can have both. You can have your cake and eat it too, and it will be nice and pretty.
And if you take a bite, you get a new cake, which is the same as the old cake, except with the bite taken out.
What I really love is watching my video screen as I'm talking, because if you've ever seen me talk before, I like to use my hands, and I'm very animated, and my hands are like lagging behind my talking by about 10 seconds. So if you're just looking at me talking, I'm sure it's like very confusing as to like why my hands are coming together while Mads is talking. I'm not like clapping at Mads. Like I was actually using it for my own little spiel there.
You clap at me altogether too little, Jared. Okay.
So one question I have is, because you market it as factory, like, is there any assumptions that the thing actually gives you back a new instance? Because in immutable collections, for example, we very often also have factory methods because we're cheating. We have things like immutable array create, where you pass an IEnumable, and if the IEnumable happens to be an immutable array, we don't even give you a new instance. We just give you back the instance you gave us. Would that still work with that, or would that break things?
It would break things. So part of when you really kind of look at like what would factory methods be important for? Like factory methods, if we didn't do init only, you could say anything's a factory. It doesn't matter, because all object initializers can do today is mutate properties which are get set. So who cares? Like it's an object construction. Once you get into init only, we've really kind of said that construction happens in phases. We basically said there's the constructor, and then there's a period of time where you can kind of mutate some of the state that makes up the object, but then the construction is done and the object is now immutable, and we don't want you to change it going forward. So there is a tension now in the language between like making object initializers more usable and respecting how we want to do the construction. And when we talked about factory methods, what we said is the way to kind of solve this is to say, like, these are really just named constructors. And so in order for you to mark something as a factory method, it has a very limited set of things it can return. It can, for instance, say return new, because then we know you're giving us back a new object where construction is not complete and we can change the values. It can chain into a factory method so that this is true. And then there's a couple other values that you can probably return from factory methods, like default. Null is a potential one. Andy's going to unmute himself and say null is a bad idea.
It's a terrible idea.
He's not. Okay, terrible. I was wrong. Sorry. Null is one where we're kind of debating, like, should that be allowed or should that not be allowed? Because it does kind of invalidate some assumptions you would have from constructors. Like, for instance, new in C# generally never returns null unless you've done something very bad in unsafe code. But there would be some restrictions that come with factory methods to make sure that all of the invariants that we want in the language continue to be held.
More broadly, it's a safety concern that there are certain rules that init has to follow in order to be safe according to object construction and verifiable. And so having those restrictions enforced for anything that's used in the presence of init is a follow-on requirement.
Right. So that's not to say that you can't have those factory methods that return that might return the same object. You just don't get to, the language won't treat them as factory methods. You don't get to call them factory methods, and therefore you don't get to have object initializers applied to them after. That's essentially, I mean, we're not preventing you from doing it, but we're preventing you from then mutating an existing, maybe long-lived object and making, doing something problematic there. So I think, so now we saw a bunch of features that are not records, but that play into that record story very nicely. And maybe it's a good time to come back to records and see how, in some ways, that they play back in because of init only. You now have this completely nominal way of declaring a record. The one you saw in the demo used constructor parameters, and those would then double as members. But you don't need constructor parameters on a record. You can do it totally in a nominal way, like we did with the hierarchy before, and still get those nice things. You get your nominal creation just for using init only. You get non-destructive mutation because you have a with method generated for you. And you also get value equality generated for you the way that we saw in the demo. And so putting the record on really gives you those last two things based on the members that you declared. Now, an interesting question is, should you also, this is pretty terse and nice. That nominal creation really gives you gets rid of a lot of boilerplate for you. But should it be even nicer? Should it be even terser? Should there be some sort of an abbreviation pattern? Should public be the default, for instance, in records? That's an open question for us right now. Maybe all the members are public by default, just like they are in interfaces, because you're expected to not have a whole lot of private implementation detail. The sort of sweet spot, the intended scenario for records is you declare your data, maybe a little bit of functionality on top of it, but there's certainly not a lot of encapsulation or hidden stuff going on. So maybe public is just the default. Maybe, tell us what you think. And maybe, this is one that we've, this sort of like the extreme of it is maybe the default, if you don't specify any accessibility or bodies or whatever, maybe these aren't fields by default. Maybe they actually declare the properties and the backing fields automatically. This is probably extreme, but it has the nice property that you really get one-liners, right? That would sort of take it to the records are super, super terse, and they fit on one line nicely, even on an 80-character display, and you just get all the property-ness for free as well as all the other stuff. So that's sort of the spectrum that we have to find our place on, and we haven't really found it yet. We haven't made a decision here yet. Of course, you saw the version with the constructor parameters. We think it's really nice to be able to declare constructor parameters directly on the class/record name. That's another potential like generalizable feature of having primary constructors that are declared on the class. And this is essentially the example we saw in the demo. And that would just, if you do that in records, that would just mean that by default you get these members declared in the body of the class. And I think that marks the end of what I had in slides. So any comments or questions in this bit?
So my major takeaway is that next time we design naming conventions, we should not have differences between members and parameters, because that causes way too much pain.
Yes.
I would say that it's a little bit different for records because records, the parameters are meant to be public surface area. That records are kind of unique in that everything is public surface area. So it makes more sense when you think of methods as being separate, that their implementations are not necessarily the surface, but records kind of break that encapsulation.
Yeah, I would argue though, like the way, VB I think had named argument calling conventions from day one, I believe, right, which C# added later as well. Like I think parameter names are effectively always part of the public API surface. Assuming the method is public, of course.
That's true. Because of named parameters, they are always public APIs. That's also true.
But named parameters were only added in C# 4 long after. VB had them all the time, but in C# they were only added in version 4, and in VB it's not case sensitive. So so we were kind of caught by our own by this feature coming in late, essentially.
Yeah, I guess that's true. I think Pascal had Pascal naming conventions for parameters as well, when I remember correctly. Which I think I never liked aesthetically, but like I dislike the cognitive dissonance that we maneuver ourselves into with both tuples and constructors in general now. That it would be really nice. We saw this in JSON, for example, where if you construct a JSON object and you happen to have a constructor that takes all the things, we would like to bind property names to constructor parameters, right? And like because the naming never matches, you always have to play this dance of saying, well, we ignore the casing, but that's also not always the right thing to do when you're case sensitive. So I think it would have been all easier for the stack if you would have not have that difference. But hey.
So you're saying we should have been like Java and had lowercase methods?
Well, to me, it's more like I think the thing with naming conventions is I think you kind of have to be a visionary early on and imagine how things relate to each other, and things that are supposed to be the same probably should, or that should be mapped somehow, probably should have had the same naming convention, right? Otherwise, you screw yourself pretty badly. But yeah.
Yeah. I think it's also
2020.
Yeah. It's also a tradition that is a bit Roman letter centric, right? That you differentiate on casing, because not all languages do that. And yeah, it's probably better getting rid of. But
yeah, in Roslyn, I had to fix a whole bunch of Turkish I related stuff in V1 and learned all about the horrors of case insensitivity.
Mm-hmm.
Yeah, so one thing that I wanted to ask, like, I think I missed it when I grabbed my Coke, like use the record keyword here, and the area samples you had the data keyword. Is this just different points in time, or do they mean different things?
They mean the same thing. They're different points in time, or they reflect the fact that we haven't fully settled, and maybe Andy in February had a different default in his mind than I did in April.
Okay, that makes sense.
So they're meant to be the same thing.
It's mostly that for an implementation, you just have to pick something. It doesn't particularly matter that much.
I mean, we can be happy that you didn't pick Andy as the keyword, right?
I'll keep that in mind for the next feature. Unless it turns out really bad, in which case I'll pick Jared.
I think that's for the returning null feature from constructors. So the one question that popped up in the chat a few times, which I think you guys have already answered in the chat, but it might be worthwhile doing on the stream as well, is what happened to extensions everything? Is that still something we are looking into, or did we convince ourselves that that's a bad idea?
We kind of put it on hold while we were going all out on records, and it's not slated for C#9. One quote unquote mistake that I did maybe a year and a half, 2 years ago, was to propose a set of features that was very involved, and that extension everything got tangled up in. So it went from being a neat little compiler trick to being something that would require runtime changes and so on, if done right, or for some notion of right. It's something that we will return to, and it's actually kind of it's a key element in one vision for where C# could go. So it's definitely not something we've given up on.
And another thing, one thing Matt said there, he said a little compiler trick. One of the problems we found is we had a design. We have a really good design for extension everything. Like, if I'm sure Mads has a note somewhere where he had kind of a different take on it and how we use like the class syntax and make it much more normal. And then when Ashley Houck was an intern a few years ago, we actually had her go off and say, like, let's do it. Like, let's implement this. Let's make it work. And what we actually found out was this kind of violated an internal assumption in the compiler that we had about how we kind of represented methods. Like, if you think of extension methods, you can represent them two ways. You could represent them kind of as an instance method. Like, is this like a receiver and a series of arguments? Or you could say, no. Extension methods, it's just syntactic sugar. Just in the compiler, immediately just rewrite everything to a static method and we're all good. And you could just move on from there. And it turns out we kind of picked one way in the compiler for extension methods, and it clashes head on with the new way that we wanted kind of to design them. And we found out that instead of being kind of some parser and like kind of some syntactic magic tricks under the hood, it's actually going to be a somewhat involved feature for us to complete. Now, that's not to say we won't do it. And the intern project was a success in that we actually did get some working implementations done, and we now have a much better understanding of what that cost would be if we take on that approach.
The second part of that is that when we started digging deeper, extension everything also started questions about, what about extension interface implementation? Should you be able to extend a class and implement an interface that it previously didn't implement? And that is not a small compiler hack. That's a lot of work. So we need to think about exactly what we want to do there, and it's probably going to incorporate CLR design changes in order to make that work.
And then from there, we look at shapes as well, which we've had several exploration proposals on C# Lang that Maz and other people have posted around structural style typing in C# instead of true nominal style typing like we have now. I know we're looking at we're going to start talking about some of that for C# 10. At least
although no structural typing in Maz's proposal,
right?
If I remember correctly.
There's been several proposals.
Yeah. So
the current one is still nominal.
Yes.
Right. It's nominal, but in a way that just how a class can implicitly implement members from an interface, even with members that it itself has inherited from a class that doesn't implement the interface. Like they just happen to match up with names and everything works out in C# today. It's structural. The proposal that I have out there is structural in that sense, that you can say, like, as I put this extension on a class, you can put an interface on it, and it could happen to match up. So that's kind of a structural thing that's already in C# today, in a limited sense. Anyway,
I have to jump off the call, everyone. I have to go handle an infrastructure issue. It was great chatting with everyone today, though. Look forward to seeing you all again.
Bye, Jared. All right, I think we are kind of out of questions. I think the thing you just talked about kind of answers all the things that came up with shapes and higher kind of types as well. So I think then this is it. Is there anything else that you want to talk to? Call to action? Looking at proposals, giving feedback or anything like that?
Is there a rule that we're out of questions when somebody asks about higher kind of types?
Higher kind of types was actually one of the first questions on the Twitch chat that I was answering on the chat earlier.
It's not a Q&A if there's not a question about higher kind of types.
Also, somebody mentioned source generators in the chat.
Jared left.
Jared just left. He did post a comment to the YouTube chat. I will read. Source generator's initial prototype was merged into our main branch a week ago. There was a blog post in the works that should go out next week sometime that gives our roadmap. But pretty much we're going to be shipping an initial version of an API. This is not, if you've seen the C# Lang proposal for replace original, this is not that. This is purely additive source generators where basically a analyzer style type API is exposed that you can provide additional source files. You can't change existing things about source, but you can provide additional source. And yeah, so we are going to be doing it's not really a language feature so much as it is a compiler feature, and it's going to be a slow burn of, all right, we're going to ship this API in preview and we're going to get feedback from people who want to use it, and then we might break things in the future until we're ready to declare it stable.
I love it. I'm looking forward to that. That's one of the features that I always wanted to play with more.
Yeah, we will have prototypes out soon.
For some reason, analyzers don't excite me as much as code fixers and source generators, because just yelling about the source code is nowhere near as interesting as actually doing something with the source code. Yeah, so...
You say that, but I really would like you to yell about some of the source code in my application.
Oh no, for sure. I mean, like I don't know whether people are aware, but like my team is heavily investing in writing analyzers for the next release of .NET 4, right? .NET 5, right? We will have a bunch of built-in analyzers, and the idea is that we will have a bunch of on by default analyzers that people just always get, right? They don't have to reference a NuGet package, they don't have to do anything to the project file. They just get like built-in analyzers. The thing we are still struggling with, and that's the general problem with all the things that yell about the source code, is what should be on by default, right? Like how noisy do we want to make it? And because there's always a trade-off between, you know, correctness and stylistic things, and unfortunately there is a continuum in between. So just yesterday we reviewed an analyzer that basically yells about argument exception construction when you don't initialize the param name correctly, right? Where we basically pass in a string that is not actually a parameter in the method you're currently in. And we ran it over our own code base, and it flags a shit ton of stuff, right? In internal implementations where, yeah, if that ever happens, you know, we consider that a product bug or a crash anyway because something bad happened, but people misconstruct these things all the time. So if we turn it on by default, chances are in a real-world code base, we will probably flag 100 of them, right? And then do we care enough? I don't know. Maybe, maybe not, right? And I think that's the thing that, you know, it was also for the compiler people, right? Like you guys also talked about what warning waves and other mechanisms, how people can kind of selectively opt into how much yelling they want to receive versus how much noise, right? And that's kind of the thing we trying to figure out.
Always a balance.
Yeah. No, it's super exciting. I mean, yeah. Speaking about yelling, somebody says any update on simplified null argument checking.
We did a lot about. I'm not exactly sure which feature that's referring to.
I'm assuming this is null bang, parameter bang.
Yeah, that's what I was thinking.
Oh, I don't know.
I think we want to do it, but I don't know that we have.
With a timeout.
Yeah, we have pulled the trigger on having someone go implement it. Or that
well, we have most of the implementation. We need to figure out. We need to figure out a syntax.
Yeah, I think we were a little worried about using postfix exclamation mark for this because in expressions now with a nullable feature, it sort of means the opposite. It means like don't worry about nullability here, and on parameters it would mean worry very much about nullability here because I'm actually going to throw an exception at you if you don't. So we're a little uncomfortable. We've talked about maybe having double exclamation mark or something be the syntax, and I think that we need to settle that. But I think that it is a useful feature. Again, actually independently of nullable reference types, it's a useful feature because so much of the argument checking code that people write is about checking for null. I don't have a percentage, but I bet it's high. So if you could abbreviate that, that would really, really save you some boilerplate.
Yeah, I don't have a percentage, but like the one thing that we looked at some point was the code contracts library in the BCL, because some people on the team really pushed that and adopted it very broadly. And we looked at all the contracts that we actually used, and I think 95% of them were just requiring not null. And so I think most of our argument checking is in that realm, right? So that's, and pretty much in the BCL, every public method has argument checking. So that's pretty much, you know, all the APIs we have at least one argument check for now.
Right. And then, of course, there's one thing is what are you checking for? The other is what do you do if you find it? But again, I think that the vast majority of the null checks will throw an argument null exception, right? That's with the name of the property. So we could totally generate that and serve most of the scenarios. We really just need to decide on the syntax.
Which is easy.
There was one question, what's the status of target type new? That was merged yesterday, day before to master, something like that. And it was actually contributed by an external contributor, Ali Reza, who over the course of many months implemented target type new. So that should be in 16.7 preview 1.
And that means basically I can say new without any type name, right? And
dictionary of XYZ, blah, 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 X equals new, open, close.
Provide a dictionary initializer.
Yeah.
Or maybe you have arguments for it, or
Nice. So I think this is it then. I think we answered all the questions. We had a very steady stream of people asking questions. Then I think this is it for today. Yeah, I think there's a blog post coming next week that somebody promised, right, about source generators, right, or at least in the foreseeable future. And then we'll probably post more updates as we're shipping more previews of .NET 5 as well. And then there will be some language features in there as well. And then I think this is probably it until further notice.
Yep. And then one last question was like about analyzers and performance. We'll have to look more into that. I'll just answer that as I guess as the person who does a lot of performance work on Roslyn. It's really hard to know what the cause of any given performance issue is. It's just like, it's hard to automate, right? Most times it's just me looking at a trace saying, oh, that's a problem. But it's hard to figure out exactly what the cause is. So we'll have to think more about that. And it is a little bit tricky in that analyzers run as part of the compiler, so it's very difficult to differentiate. One thing that we are thinking about doing is just making a universal flag for the compiler to say turn off all the analyzers. And that would at least make it easier to figure out whether your performance issue is a compiler issue or an analyzer issue. And that's probably going to happen pretty soon.
Yeah, especially as we're adding a bunch of built-in ones, right, where the customer has no option to easily turn it off.
Yeah, exactly. Right.
All right, then wave everybody, and then we say goodbye until like in a few weeks. If there's more stuff coming. Bye-bye.
See ya.
Bye. Thanks for having us.